Components monitored, monitoring example. Now we come for components monitored. Monitoring hosts, accessibility, hardware components, HBA, NIC, graphic card, internal disk, status of various process and applications has to be accessed. Capacity, file system utilization, database. In database you come across table space, log space, utilization, user quota. Performance, when you come for performance, it is CPU and memory utilization, transaction response times. Security, when you come for security, it is login, authorization and physical security. Then when you come for accessibility, it is fabric errors, zoning errors, ZBIC failure, device status, attribute change, processor card, fans, power supplies. Capacity, when it is capacity, it is inner switch, link and port utilization. Performance is based on connectivity devices and connectivity ports. When we come for connectivity ports, it is link failure, loss of signal, link utilization has to be monitored. When it is connectivity devices, it is port statistics. Security, zoning and LAN masking, administrative tasks and physical security, which includes authorized access and strict password. Monitoring storage arrays, accessibility, all hardware components, array operating environment, which includes RAIN, environmental sensors, replication processes. When you come for capacity, configured and unconfigured capacity, allocated, unallocated storage, fan in, fan out ratios. Performance, it is FE and BE utilization throughput, input output profile, response time, catch metrics. Security, it is physical and administrative security. Monitoring examples, a storage infrastructure requires implementation of an end-to-end solution to actively monitor all the parameters of its components. Early detection and preemptive alerting ensure uninterrupted services from critical assets. In addition, the monitoring tool should analyze the impact of feature and reduce the root cause of systems. Accessibility monitoring, failure of any component might affect the accessibility of one or more components due to their interconnections and dependencies. Consider an implementation in a storage structure with 3 servers, H1, H2 and H3. All the servers are configured with 2 HBAs, each connected to the production storage array through 2 switches, SW1 and SW2. All the servers are 2 storage ports on the storage array and multipath software is installed on all the servers. If one of the switches S1 fails, the multipath software initiates a path failover and all the servers continue to access data through the other switch SW2. However, due to the absence of redundant switch, a second switch failure could result in inaccessibility of the array. Monitoring for accessibility enables detecting the switch failure and helps an administrator to take corrective action before another failure occurs. In most cases, the administrator receives symptoms alert for a failing component and can initiate actions before the component fails. So you have a diagram that represents all these servers with applications, switches and storage arrays to look over. This is accessibility monitoring example, array port failure. And the next one is we come across for HBA failure. The same diagram, it is represented with the marking. Then it is switch failure where it is marked. Then capacity monitoring. Servers H1, H2 and H3 are connected to the production array through 2 switches SW1 and SW2. Each of the servers is allocated storage on the storage array. When a new server is deployed in this configuration, the applications on the new server need to be given storage capacity from the production storage array. Monitoring the available capacity on the array helps to proactively decide whether the array can provide the required storage to the new server. Also, monitoring the available number of ports on SW1 and SW2 helps to decide whether the new server can be connected to the switches. You have a diagrammatic representation of monitoring storage array capacity where you have your hypervisor, application servers, switches and production storage array which is interconnected. Then it is capacity monitoring example with storage array with new servers, host servers with application, switches and the storage array. Monitoring server file system space. Figure illustrates the environment of a file system when full, and that results in application outage when no capacity monitoring is implemented. Monitoring can be configured to issue a message when thresholds are reached on the file system capacity. For example, when the file system reaches 66% of its capacity, warning message is used, and a critical message is issued when the system reaches 80% of its capacity. This enables the administrator to take action and to extend the file system before it runs out of capacity. Proactively monitoring the file system can prevent application outages caused due to the lack of file system space. You have a diagrammatic representation for capacity monitoring example, file system space. Okay, where you have the warning message, then the critical message, everything with 66% and 80%. Performance monitoring. In this example, servers H1, H2 and H3 with 2 HBAs are connected to storage arrays through switches SW1 and SW2. The 3 servers share the same storage ports on the storage array to access LUNs. A new server running an application with a high workload must be deployed to share the same storage port as H1, H2 and H3. Monitoring array port utilization resources that the new server does not adversely affect the performance of the other resource. In this example, utilization of shared storage port is shown by the solid red and dotted lines green in the graph. If the port utilization prior to deploying the new server is close to 100%, then deploying the new server is not recommended because it might impact the performance of other servers. However, if the utilization of the port prior to the deploying the new server is closer to the dotted line green, then there is a room to add server. So you have a performance monitoring example, array port utilization with servers and storage arrays. Performance monitoring. Most servers offer tools that enable monitoring of server CPU usage. For example, Windows Task Manager displays CPU and memory usage. However, these tools are inefficient at the monitoring hundreds of servers running in a data center environment. A data center environment requires intelligent performance monitoring tools that are capable of monitoring many servers simultaneously. We have a diagrammatic representation of server CPU utilization. Now CPU usage above 90% for the last 90 minutes has been mentioned. Security monitoring. In this example, the storage array is shared between two work groups, WG1 and WG2. The data of WG1 should not be accessible to WG2 and vice versa. A user from WG1 might try to make a local replica of the data that belongs to WG2. If this action is not monitored or recorded, it is difficult to track such a violation of information security. Conversely, if this action is monitored, a warning message can be sent to prompt a corrective action or at least enable discovery as a part of regular auditing operation. An example of host security monitoring is tracking of login attempts at the host. The login is authorized if the login ID and password entered are correct or login attempt fails. These login failures might be accidental or a deliberate attempt to access a server. Many servers usually allow a fixed number of successive login failures, prohibiting any additional attempts after these login failures. In a monitored environment, the login information is recorded in a system log file, and these successive login failures trigger a message warning of a possible security threat. We have a diagrammatic representation of security monitoring example where you have work group 1 and work group 2. A warning message has been given which has been indicated.